Bismillahir Rahmanir Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Section 2.7 The Tangent Line Problem. The aim of this section to derive a formula to get the slope of the tangent line to the graph of a function f at a point a, f of a, and to write the equation of the tangent line. So if we have, for example, this one, a tangent line L to a graph at a point B, so our function is y is equal f of x. This function is continuous and has a tangent line at L. And we want to know what is the slope of this tangent line, or what is the equation of this tangent line. We have just a point B, which is a f of a, and we have the line L that passes through this function at the point A. Let us have this graph of a function y is equal f of x, which is a continuous function, and this function has a tangent line L at the point A, and this is the point B, where B is at a f of a. And we know that to have an equation for any line, we need two things. Either we need 2 points to write any equation for a line, or we need 1 point and slope. For this line, tangent line L, we have a point which is a f of a, but we don't have a slope. Also, we don't have another point. So we will use something which is called a secant line, which is a line that cuts the graph at 2 points. So according to this, look at this graph. Here we have two lines, the line L. This line cuts the graph at 1 point. Where is the line here? The secant line, the green one, cuts the graph at 2 points. The first one is P, where the B is a f of a, and the second point, it is Q. And at Q, if we say this Q is at the point A plus H and FA plus H. So the green line, we call this line is the secant line. It cuts the graph at the point P, A f of a, and at the point Q, where Q is A plus H, FA plus H. So now we have the line which is the green one. So we say that at the point B we have the direction A f of a, and at Q we have a plus h and fa plus h. So here we have 2 points, and we know that for the slope, to find the slope for any line, we know that the slope is given by delta y over delta x, where delta y is equal y1 minus y2 and delta x is equal x1 minus x2. So this one, if we say this one is x1, this one is y1, this one is x2, this one is y2. So to find the slope of this line, which is the secant line, the green one, we'll say this slope is equal secant. So m represents the slope and secant represents the secant line. So it will be delta y, so it will be y2 minus y1, or you write it y1 minus y2. It doesn't matter. So if we write, for example, fa plus h minus f of a over then a plus h minus a. So this will give us fa plus h minus f of a divided by a will cancel with minus a, we left with h. So this is the slope of the secant line. But how can we benefit from the slope of the secant line to find the slope of the tangent line? We took this secant line at this pass through the point A, f of a, and through the point a plus h, fa plus h. If we take another secant line which is pass through the same point B, and we get this one is close, so for example if we take it here, so it will be the same slope and our h will be small, where h is the distance between a and a plus h. if we draw another line which is close and close, so whenever you get your edge close and close, the final result you will see that the secant line will be the same as the tangent line. So whenever you come close and close to the point A, you make your edges small as much as possible, the secant line will be the same as the tangent line. So if your edge is too small, that means the secant line is the same as the tangent line. And from here we say that the slope of the tangent line will be the limit of the slope of the secant line as h approach to 0. So m tangent, which is the slope of the tangent line, will be limit of the m secant as h approach to 0. And this is the relation between the tangent line, the slope of the tangent line, and the slope of the secant line. Because if this edge gets close, so for example the first one we take it here, then the second line will be there, passing through this point and this point. Then you get your edge is small, then it will be here. Then your edge will be small, the line will be here. So whenever you get close and close to the point A, that means your edge become close and close to 0. That means we have the same line. So m tangent will be limit of m secant as h approach to 0. يعني نحن عندنا معادلة، نريد نجيب معادلة الخط اللي هي هذا المماس. عندنا نقطة واحدة، نعرف على أساس نجيب المعادلة لأي خط مستقيم لازم يكون عندنا 2 points أو على الأقل point وسلوب. طبعا نعرف هنا عندنا نقطة واحدة فقط، على أساس كذا ما نقدر نجيب السلوب. فإيش بنسوي؟ بنستعين بالسيكنت لاين اللي هو القاطع، يعني the same line يمر بالنقطة B اللي هي نفسها عند التانجنت لاين، ونقطة ثانية اللي هي Q. طبعا بما أن عندنا نقطتين إذا نستخدم القانون على أساس نجيب السلوب، يطلع لنا بهذا الشكل FA plus H minus F of A over H. بعدين قلنا بما أنه نحن قدرنا ناخذ اللي هي السيكنت هنا اللي هي ال H، المسافة ما بين ال A وال A plus H عبارة عن ال H. لو أخذنا سيكنت ثاني اللي هو هنا عند النقطة هذه، إذا ال H عندنا إيش بتكون؟ أصغر. طيب لو اقتربنا أكثر وأخذنا ال H البوند Q هنا، إذا ال H صارت أقل. كل ما لاحظنا أن نحن نقترب من ال A، إذا ال H بتكون تقترب من الزيرو، وبيصير عندنا إنه السيكنت لاين ينطبق على التانجنت لاين. إذا معناته إنه slope للتانجنت لاين يساوي limit of slope of the secant line whenever H approach to 0. We have the point P and we have the point here is Q, the secant line passing through the point BQ and the tangent line passing through the point B. So we can derive the equation, or we can derive the slope of the tangent line from the slope of the secant line. And this is in definition 2.7.1. Tangent line with slope. So let y is equal f of x be a continuous at a number a if the limit m tangent is equal limit of fa plus h minus f of a over h when h approach to 0 exists, then the tangent line with the graph of a function f at a f of a is that line passing through the point a f of a with a slope m tangent. So if your function is f is continuous and you have a tangent line which is passing through the point a f of a, the slope of this tangent line is given by limit of fa plus h minus fa over h when h approach to 0. And note here, if the limit in 2 exists, so that means if this limit exists, the number m10 is also called the slope of the curve y is equal f of x at the point a f of a. So sometimes it's called m tangent, sometimes it's called the slope of the curve, which when is used, it will be the same meaning, which is called the m tangent or the slope of the curve. So here we have guidelines for computing this limit or for computing the m tangent. First we need to evaluate fa and fa plus h. Then we need to evaluate the difference between fa plus h minus f of a and simplify it. Then we need to simplify the difference quotient, which is fa plus h minus f of a over h. And the final step, we need to compute the limit of the difference quotient, which is the limit of fa plus h minus f of a over h when h approach to 0. Now let us see the first example, which is find the slope of the tangent line to the graph of y is equal x squared plus 2 at x is equal 1. So here we have our function f of x, and x is equal 1, that means our a is equal 1. We need to use the definition to find the slope of the tangent line. So we need to use this limit to find the slope of the secant, or to find the slope of the tangent line. So let us see how to find the slope of the tangent line where a is equal 1. So here our function y is equal x squared plus 2, where x is equal 1. So this one is f of x. And here x is equal 1, that means a is equal 1. So we use the definition. It is given that m tangent is equal limit of f a plus h minus f of a divided by h when h approach to 0. So this will give us limit f a plus h, that means we need to go to the function f and replace any x by a plus h. So we replace any x by a plus h. We know that x or a is equal 1. So either substitute it from here directly or you leave it at the end. So if we replace our function, replace any x by a plus h, that means we need to replace it. So this is similar if I write it here, limit of f of a is 1 plus h minus f1 divided by h when h approach to 0. So f1 plus h, that means I go to the function f, I replace any x by 1 plus h. So it will be 1 plus h squared plus 2 minus f of a, that means f1. So f1 will be 1 squared plus 2. So this is divided by h, and we evaluate the limit when h approach to 0. This will give us limit when h approach to 0 of 1 plus h all square. This will give us 1 plus 2h plus h square plus 3, and here we have minus 1 square plus 2, so this will be minus 3. Sorry, this one is plus 2, not plus 3, divided by h. So now we need to simplify our function, so this will be equal. Here we have 1 plus 2h plus h square plus 2 minus 3. So 1 plus 2 will be 3, minus 3 will be 0. So this one will cancel with 1 plus 2 will be 3, minus 3, this will give us 0. So we left with limit. So here we left with limit of 2h plus h squared divided by h when h approach to 0. This will give us, if we take from the numerator h as a common factor, so limit of h, then we left with 2 plus h divided by h when h approach to 0. So then again here we can cancel h with h. So we left with limit of 2 plus h when h approach to 0. Just we need to replace h by 0, so it will be 2 plus 0. This will give us 2. So we conclude here m tangent is equal